The most important concept of complex numbers, one more important, just like modulus, is argument. This is very important. Argument of complex numbers. Argument means the value of theta, the unique value of theta that lies between minus pi to pi. Of course, it may take the value pi. That lies between minus pi to pi. Such that if that is x plus iy, then theta is tan inverse of plus tan inverse of y by x. Of course, if z lies in the first quadrant, this is y, this is x. This is the angle. This angle is known as principal argument. That is called principal argument. Of course, the general argument is taking 2n pi. The same angle may be represented by 2k pi plus theta itself. The same angle may be represented by 2k pi plus theta, where k is an integer. So, suppose z lies in the first quadrant. The principal argument is theta. If z lies in the fourth quadrant, the principal argument is minus theta. If z lies in the second quadrant, the principal argument is pi minus theta. Okay. If the point A lies in the third quadrant, the principal argument may be considered as minus of pi minus theta. That means minus pi plus theta itself. So, it's based on the complex number, you can consider like this. Okay. Suppose I will take like this. In the first quadrant, the first, that is x plus iy. X positive, y positive. Then this is theta equal to tan inverse of mod y by x. Of course, the modulus gives us the positive value only y by x. That is the principal argument. In this one, minus theta. Okay, minus tan inverse of mod y by x. In this one, for the same complex number, once it lies in the fourth quadrant, once it lies in the second quadrant, pi minus tan inverse of mod y by x. Once it lies in third quadrant, minus pi plus tan inverse of mod y by x. Of course, whatever x and y may be, except whatever x and y may be. The principal arguments are considered as theta, pi minus theta, minus pi plus theta. The principal argument always lies between minus pi and pi. Once the complex number lies on x-axis, the principal argument is 0. Okay. For this, the argument is 0. If the point lies on negative real axis, the principal argument is pi. Once the point lies on, that means the complex number lies on, it is purely imaginary, positive imaginary power. Then the principal argument is pi by 2. Once it lies in this one, the principal argument is minus pi by 2, because the principal argument always lies between minus pi and pi. That means z lies on positive x-axis. Then argument of z, principal argument. See, if z lies on positive y-axis, then the principal argument of z must be pi. If z lies on negative x-axis, the principal argument of z is pi. if z lies on negative y-axis, the principal argument of z is minus pi. Like that. And once it lies in the first quadrant, it lies between 0 and pi. Of course, 0 and tan inverse of mod y by x. For example, I will take like this 1 plus root 3i minus 1 plus root 3i. The principal argument of z. The principal argument of z is, since this is negative and this is positive, it lies in the second one. So I will take the principal argument as pi minus tan inverse of, taking the modulus of these values, we get y by x is root. Taking positive sense. Tan inverse root 3, pi by 3. So 2 pi. Like that, you can get the principal argument, amplitude, otherwise you can call it as amplitude. Principal argument means the angle that OP makes with the positive direction of x-axis. This angle I am taking into consideration. Of course, based on the, once this point lies in this one, you are taking this angle. Once this point lies in this, you are taking this angle. Once this point lies in this, you are taking pi minus of this angle. Once this is theta, this angle that we consider. Like that. Once it lies in, you have to consider minus pi plus theta. Okay, that is the principal argument. The general argument is different. The general argument of the complex number is once the argument of that is theta, the general argument of that is the principal argument. General argument is considered as 2k pi plus theta itself. 2k pi plus theta itself, where theta is the principal argument of z. That gives us k belongs to z. K belongs to, of course, like that. You are taking the same. This is the general argument. This is principal argument. Principal argument is always unique, but general argument is not unique. That should be observed here. Principal argument is always unique. Theta or y minus theta or minus theta or minus pi plus theta. But whereas the general argument is 2k pi plus theta. Once the principal argument of z is equal to 2 pi by 3, and it lies, of course, the general argument of the same complex number is 2n pi. I will take like this: 2 pi by 3, 2 pi by 3, where n stands for an integer, positive integer, of course, like that. A complex number may be represented in its Euler form, Euler form or Euler form, Eulerian form of complex number. If z is a plus ib, then mod z is square root of a square plus b square. It is considered as OR. Then z may be represented by OR into a by root a by r plus and b by I b by r. Once you consider this one as cos theta plus this is sin theta, where theta is the principal argument, of z, then you can say that this is the polar form of z, the polar form of this, or it may be written as r into e power I theta or r into cis theta. These are all different forms of the complex number. This is polar form. This is called polar form. This is exponential form. This is cis form of the complex number. So z may be written as mod z into e power I theta, where theta is the principal argument of z. Okay, like this you can take the polar form or Euler form or exponential form like this cis form of the complex. Okay. That is one more where argument of z is principal argument of z is theta of that complex. Now, coming to different powers of I. Different powers of I square is minus 1. I cube is I square into I. That is minus I power 4. That is I square whole square 1. I power 5 I power 6 I square, which is nothing but minus 1. So, like that, once you consider I power 4n, where n stands for an integer, it is nothing but I power 4 is 1, so that is clearly 1. I power 4 plus 1 is I power 4 n plus 2 is I square, that is minus 1. I power 4n plus 3 is I cube, that is minus I itself. I power 4n plus 4, again 1, the same value repeat. So, once you observe these 3, 4, or these 3, 4, the sum is 0 k. That means, if you consider I power 4n plus 1, I power 4n plus 2, I power 4n plus 3, I power 4n plus 4. Well, this is I, this is minus 1, this is minus I, this is 1. Again, of course, which is nothing but I here. I square is minus 1 here, I cube is minus I here, and this is I power 4 is again 1. So these stands. Sum of the successive powers, 4 successive powers, sum of 4 successive powers of I is always equal to 0. One more example, 1 plus I square I cube I power 4, that you consider like this. This is 1 minus 1, I cube is minus I power 4 is 1, I power 4. Oh, this is 1 plus I square. Sorry, this is I. So successive, 4 successive powers of I. 4 successive powers of I is clearly 0 itself. You can remove this. Similarly, 1 plus I square plus I power 4, that you consider. I square 1 plus I cube is there. Plus I square is minus 1. I cube is minus 1. So you can remove this. That means I power 0 is 1. I power 0 plus I power 1 plus I power 2 plus I power 3 is always 0. Sum of 4 successive powers of I is always equal to 0. And one more important point, once you consider 1 plus I by 1 minus I, 1 plus I by 1 minus I is nothing but 1 plus I into 1 plus I by 2. 1 minus I into 1 plus I is 2. Taking this 1 plus I whole square by 2. That is 1 plus I square plus 2I by 2. I square stands for minus 1. You can remove this one and you can remove this one. This is I. So the value is I. Similarly, 1 minus I by 1 plus I is 1 by I, which may be written as I square, I by I square. I square is minus 1, that is minus I. So 1 plus I by 1 minus I is I. 1 minus I by 1 plus I is minus I. These points are Uttama points. These points are very important points. Okay. Okay. Square root of a complex number. The square root of complex number psi. Let square root of a plus I be x plus I. Of course, plus or minus. The square root gives us plus or minus x plus I. Now squaring on both sides, so we get a plus ib is x plus iy. That is x square. I square y square is minus y square plus 2i 2x. So this is x square minus y square is 0 and 2xy is okay. Now x square plus y square is x square plus y square is x square minus y square whole square plus 4x square y square, which is nothing but a square plus b square. This is a square, this is b square. So x square minus y square equal to a, x square plus y square equal to a square plus the square. This is square root of a square plus x. Adding these two, we get 2x square gives the value root over a square plus b square plus a. Subtraction and 2y square gives us square root of a square plus b square minus x. From this, x takes the value square root of root over a square plus b square plus a by 2. And from this, y takes the value square root of root over a square plus b square minus a by 2. So, once a plus root a plus ib is plus or minus x plus iy, square root of root over a plus ib, root over a plus ib is plus or minus root over a square plus a b square square root of a square plus b square plus a by 2. Once here is b positive, we take plus a and y is square root of root a square plus b square minus a by 2. Once b is positive. Once b is negative, this is minus, we get minus this way. In such case, a minus ib gives us, so that plus a by 2 minus I into square root of a root a square plus b square minus a by 2. In case of b negative, this is b positive. In such a way, you can able to find the square root of a complex number. The square root of a complex number. Okay. Similarly, so once x plus iy is given, this is square root of root over x square plus y square plus ax by 2 plus I into square root of root over x square plus y square minus x by 2 if y positive. In case of y negative, root over x square plus y square plus x by 2 minus I into square root of x square plus y square minus x by 2 if y is negative. Once the here is positive, we will take positive here negative, we will take negative. That is the square root of the complex number. Suppose, for example, let us consider square root of 1 plus I. Here a equal to 1 and b equal to 1 positive. So, plus or minus square root of root over 1 plus 1 minus 1 by 2 plus I into root root over 1 plus 1, plus 1 minus 1 by, that is plus or minus root 2 plus 1 by plus I into square root of root 2 minus 1 by, that is the square root of 1 plus I. Similarly, 1 minus like that, you can find square root of a complex number. Suppose root I. What is root I? Root I means 0 plus 1 I. 1 I into 1. Right. A equal to 0, B equal to 1. So that's square root of this is 1 square plus 0 square plus 1 square, that is 1 minus 0. Of course, this is plus 0. Once this is plus I into square root of 1 minus 0, that is plus or minus 1 by root 2 plus I by root 2. Plus or minus 1 plus I by root 2 is required root I. Like that. Once root minus here plus or minus 1 minus I by root 2. So in such a way you can find the square root of a complex number. Logarithm of a complex number. How to find the logarithm of a complex number? Log of a plus I log z. Let us suppose this is z. Log of a plus I to the base c, of course. Once a plus I may be written as root over a square plus b square into a by root over a square plus b square plus I into b by root over a square. So once this is mod z into, once you are taking this one as cos theta plus I sin theta, where theta is the principal argument of z, argument of a or g. This is a or z, argument, the principal argument of z. So this can be written as mod z into e power I theta. This is written as e power I theta, exponential form of a complex. Once this is z, this is mod z e power I theta. Taking logarithm of that z, log of mod z into e power I theta to the base e, which is log mod z to the base e plus log e power I theta to the base g, which is log mod z to the base e, because this is real you can take and positive. Moreover it is non-zero, then you can take logarithm here, and this is I theta, where theta is the principal argument. Okay, theta is the principal argument of that particular complex number. I tan inverse mod y by x. Once a we are positive. So once a positive, b positive. Log of a plus I b to the base e is log of root over a square plus b square to the base e plus I into tan inverse of b by a. Like that, you can find the logarithm of a complex number. Okay, that is log mod z to the base e plus I into argument of principal argument of. The principal argument always lies between minus pi and pi, including x value. That value lies between 0 minus pi and pi. Once the point lies, that means the complex number lies in the first quadrant. The principal argument lies between 0 and pi by 2. Once the point related to the complex number lies in the fourth quadrant, it lies between minus pi by 2 to 0, that means minus theta. Like that, the principal argument can be considered. So, This is the logarithm of the complex number. Let us consider log I. Log I to the base. Log I to the base u. Here a equal to 0, b is 1. A equal to 0, b is 1 means this is log modulus of 1 plus 0 plus 1 I. 0 plus modulus of 0 plus 1 I to the base e plus and I into tan inverse of 1 by 0 b by a. Tan inverse infinity pi by 2. This is purely imaginary. The argument is pi by 2. And moreover, it lies on positive imaginary axis. Positive imaginary axis. The principal argument is pi by 2. Log 1. This is clearly modulus is 1. So log 1 is 0. 0 plus I pi by 2. And this is I pi by 2. Like that, you can able to find the logarithm of that complex number. So the logarithm of the complex number. This is the logarithm of complex number once AB is positive. This is the logarithm of the complex number. Okay. Based on these concepts, we will go through certain problems. We will go through the certain problems. If Z1 comma Z2 or two complex numbers such that mod Z1 equal to mod Z2, the modulus values are equal, and argument of Z1 plus argument of Z2 is 0, then Z2 is 0. Z2 in terms of Z1. Okay. The options are like this. Z1, Z1 bar minus Z1 bar D minus Z2. Like okay. Of course, none. This is none. So let mod Z1 equal to mod Z2 equal to R. Let it be R. And argument of Z1 is theta, then argument of Z2 is minus theta, since argument of Z1 plus argument of Z2 is given as 0. Argument of Z2 is minus theta. Argument of Z2 is minus theta. Okay. Therefore, if Z1 is R into cos theta plus I sin theta, then the modulus is this. Theta will be replaced by minus theta r into sine of minus minus the argument is minus theta itself. That is r into cos theta minus sin theta, which is z1 over itself, no, conjugate, the conjugate of z2. Hence, this is the conjugate of z1. Z2 is the conjugate of z1. Similarly, z2 bar is z1 bar whole bar, that is z2. So therefore, z1 and z2 are conjugate complex numbers. Conjugate complex numbers. Okay. This is the concept. If z1 and z2 are two complex numbers such that their magnitudes, the modulus, are equal, and moreover argument of z1 plus argument of z2 is 0, then both z1 and z2 are one is the conjugate of the other. One is the conjugate of the other. Suppose in the same problem, let us suppose this is pi. This is pi. Argument of z1 plus argument of z2 is given as pi. Then z2 in terms of. In such case, once argument of z1 is theta, then argument of z2 is pi minus theta. You can replace like this. You can replace pi minus theta. Hence, z2 may be written as, in such case, pi minus theta. This is also pi minus theta. Okay. Then what happens? Z2 is r into cos of pi minus theta is minus cos theta. Sin of pi minus theta is sin theta. In such case, this is minus r into cos theta minus I sin theta itself, which is nothing but minus r into z1 bar minus r into cos theta plus minus sin theta is the conjugate of this. Hence, in such case, in such case, z2 equal to minus z1 bar. So, in case of z1 and z2, in such case, z1 and z2 follows the relation. z1 takes the value minus z1 bar, minus z1 bar. Okay. z2 bar is minus z1, minus z1. So, the concept is here, once mod z1 equal to mod z2 and argument of z1 plus argument of or amplitude of z2 is 0, then z1 equal to z2 bar or z2 equal to z1 bar. One is conjugate of the other. In case of argument z1 plus argument of z2 is pi. In such case, z1 is minus z2 bar or z2 is minus z1 bar. So that should be observed. This is one important concept related to the argument of complex numbers. Next problem. if Z1 comma Z1 comma Z2 or conjugate complex numbers, then augment of Z1 into Z2, augment of Z1, Z2. We know that augment of the product of complex numbers is augment of Z1 plus augment of Z2, sum of the arguments. Augment of Z1 into Z2 is augment of Z1 plus augment of Z2. That is the property of augments. But here augment of Z2. But here Z2 is Z1, the conjugate. So hence augment of Z2 is augment of Z1 bar. Augment of Z1 is theta, augment of Z1 bar is minus theta. Its image, because this is once this is Z, this is Z bar. So once augment is theta, this is the minus theta itself. So hence this is minus augment of Z1 itself. Therefore, augment of Z1 into Z2, where Z1, Z2 are conjugate, then augment of Z1, this is minus augment of Z1 itself. So we can cancel these two, and so we get augment of Z1 minus augment of Z2 once they are conjugate. You can take it as 0 or augment of Z1, Z2 or conjugate complex numbers, you can take 0 like that. This is Z1. Once this is Z1, its conjugate is Z1, this is Z1. Once the augment is theta, its augment is minus theta. Because once this is A comma B, this is A comma minus B. The mirror image about x-axis. So the augment is theta, then its augment is minus theta. Or you can say like this. You can say augment of n pi into augment of Z1 minus augment of Z2. You can take like that. Augment of Z1 minus augment of Z2. Z1 and Z2 are conjugate complex numbers. Conjugate in the sense Z2 equal to Z1 bar. This is one important problem. If L Z2 by M Z1 is purely imaginary, then modulus of purely imaginary modulus of lambda Z1 plus mu Z2 by lambda lambda z1 minus mu z is equal to, in terms of the options are L by. Here the options are third one minus lambda by mu. Fourth one is Lz2 by mz1 is purely imaginary. Then modulus of lambda z1 plus mu z2 by lambda z1 minus mu z2 by. Given Lz2 by mz1 is purely imaginary. Suppose purely imaginary means ki, where k is since it is purely imaginary, I am taking as ki. So in such case, z2 by z1 takes the value mk by L into I. mk by L into I. So therefore, the required modulus z1 plus mu z2 by lambda z1 minus mu z2 equal to, this is, you can write as lambda plus mu z2 by z1 lambda minus mu z2 by z1. Okay, but z2 by z1 may written as dividing with z1. Lambda plus mu into z2 by z1 is mk by L into I by lambda minus mu into mk by L into I. But modulus of z1 by z2 is modulus of z1 mk by L into I by modulus of its conjugate. Once you consider this one as z, this one as mod z by modulus of z1, where z is lambda plus mu mk by L into I. Once this is considered as z, this is its conjugate. The magnitudes or the absolute value of z and z bar is same. These two are same. Hence, that is clearly one. Hence, fourth one is the right option. Fourth one is the right option. Next one. If argument of z is theta, then argument of z for elements for n being natural number. The solution is argument of z is theta, then argument of z power n is, of course, you can take it as z Z may be, that implies Z may be considered as mod Z into e power I theta since its argument is theta. So argument of Z power n is argument of mod Z power n e power I n theta itself, which is power n into e power I n theta. Okay, argument of that means of course this is argument of Z is you can take it as mod Z into e power I theta whole power n itself. That is argument of mod Z power n into e power I n theta. This is real. Argument of kz is nothing but when k is real, k into argument of z itself. So that this is nothing but argument of e power I n theta, which is nothing but n theta itself, n theta. Okay, so once argument of that is theta, the argument of its nth power is n theta itself, n theta, where n belongs to n. Okay. This argument does not depends on this value, it depends on this angle. So hence, once theta is the argument of z, that is nothing but mod z into cos theta plus I sin theta. Here z power n into cos n theta plus I sin n theta. So argument is n theta. Z1, Z2, Z3 or non-zero complex numbers such that Z2 is not equal to Z1 and A is mod Z1, B is mod Z2, C is mod Z3 and determinant of A, B, C, B, C, C, A, B is 0. Then argument of Z3 by Z2 equal to, of course in terms of the options are given, argument of Z2 minus Z1 by Z3 minus Z1 whole square. Second, argument of Z2 minus Z1 by Z3 minus Z1. Third, argument of Z3 minus Z1 by Z2 minus Z1. Z2 minus Z1 and fourth one, argument of Z3 minus Z1 by Z2 minus Z2. Z1, Z2, Z3 are non-zero complex numbers. Non-zero complex numbers Z1. So that Z2 is not equal to Z1. Z2 is not equal to Z1. Moreover, the determinant of A, B, C, B, C, A, C, A, B is 0. Then augment of Z3 by Z2. Z3 by Z2. Z3 by Z2. Given A, B, C, B, C, C, A, B equal to 0. That implies A into B, C minus 6 plus B into, of course, minus B into B square minus A square B square plus C into AB minus 6. That implies 3ABC equal to AQ plus BQ plus C. So that gives us, that implies A plus B plus C 0 or A equal to B equal to C. A equal to B equal to C. A equal to B equal to C. That is A equal to B equal to C. That means mod Z1 equal to mod Z2 equal to mod Z3. But this is not equal because mod Z1 plus mod Z2 plus mod Z3 is 0. Not possible, of course. Not possible. Since the modulus values non-zero, they are non-zero. So it cannot be 0, not possible. Or mod Z1 equal to mod Z2 equal to mod Z3. This is possible. This is which is possible for us. This one is possible, this one is not possible. Since mod Z1 equal to mod Z2 equal to mod Z3, let us take OR. Let us take, let mod Z1 equal to mod Z2 equal to mod Z3 equal to OR. And that one may be considered as OR into e power I theta. I theta. Z2 equal to OR into e power I theta 2 theta 1. This is theta. Z3 is OR, right? Because modulus values are equal. Modulus values are equal. Now consider this. Now consider Z3 minus Z1 by Z2 minus Z1. Okay. That is e power I theta 1 minus e power I theta 3. I theta 1 by, or maybe cancel I theta 2 minus e power I theta. This is cos theta 3 minus cos theta 1, the real portion of this one, plus I into sin theta 3 minus sin theta 1 by, this is cos theta 2 minus cos theta 1 plus I into, this is sin theta 2 minus sin theta. Cis form and cis form. Now apply trigonometric transformation. Now apply trigonometric transformation. Trigonometric transformation. Take trigonometric transformation cos t minus cos t. cos c minus cos d is 2 sin c plus d by 2. Cos c minus cos 2 sin c plus d by 2. That is theta 3 plus theta 1 by 2 sin theta 3 minus theta 1 by plus sin theta 3 minus sin theta 1 sin c minus sin d. Sin theta 2 cos of theta 3 plus theta 1 by 2 sin theta 3 minus theta 1 by. Similarly in the denominator we get minus 2 sin of theta 2 plus theta 1 by 2 sin of theta 2 minus theta 1 by 2 plus I into 2 cos of theta 2 plus theta 1 by 2 and this is sin of theta 2 minus theta 1 by 2 itself. Okay. Now totally you can take here I square. Taking this one as I square, you can take I as common, I sin theta 3 minus theta 1 by 2 by here I sin of theta 2 minus theta 1 by 2. You get here including 2. We get here cos of theta 3 plus theta 1 by 2 and here is my plus I square equal to plus I sin theta 3 plus theta 1 by cos theta 2 plus theta 1 by 2 plus I sin theta 2 plus theta 1 by 2. Okay. You can remove this one. It becomes real, of course. This is sin theta 3 minus theta 1 by 2 sin theta 2 minus theta 1 by 2. This is e power I theta 3 plus theta 1 by 2 by e power I theta 2 plus theta 1 by, which is the real part of some real number p into this one is e power I into theta 3 minus theta 2 by 2 itself, which is real. This is which is equal to this. So the argument square, therefore square z1 z3 minus z1 by z2 minus z1 whole square is that real square, that p square, where p is this one into e power I into theta 2 minus theta 2. So the argument of z3 minus z1 by z3 minus z2 minus z1 square is argument of this one theta 3 minus theta 2 minus theta. What is theta 3? Argument of z3 minus argument of z2, which is nothing but argument of z3 minus by z2. Hence the right option is argument of z3 minus z1 by z2 minus z1 whole square. Okay, this is one different, having different approach problem. Once the determinant is 0, then a equal to b equal to c. The magnitudes are equal. Once the magnitudes are equal, then you can take z1, z2, z3 with different arguments, theta 1, theta 2, theta 3. Now taking z3 minus z1 by z2 minus z1, z3 minus z1 by z2 minus z1. That argument is given by this value, theta 3 minus theta 2 by 2. Squaring, the argument becomes theta 3 minus theta 2. So that is nothing but argument of Z3 minus argument of Z2, which is argument of Z3 by Z2. These are the problem. Such problems are given in advance. IIT advance. Of course, even you can get it in mains also. Next problem. If Z1 comma Z2 or 2 period non-zero complex numbers such that modulus of Z1 plus Z2 is less than or equal to, of course, this is equal to mod Z1 plus mod Z2. Then argument of Z1 minus argument of Z2 argument of Z1 minus argument of Z2. Okay. Given modulus of Z1 plus Z2 equal to mod Z1 plus mod Z2. Actually, modulus of Z1 plus Z2 is less than or equal to mod Z1 mod Z2. Actually, modulus of Z1 plus Z2 is less than or equal to mod Z1 plus mod Z2. Equality follows once they lies on same line. Once they lies on same line. Triangle infinite of triangle infinite. Let us take like this. Squaring on both sides. Z2 whole square is mod Z1 square plus mod Z2 square plus 2 mod Z1 mod Z2. But this is Z1 plus Z2 into this is Z1 bar plus Z2. Since this one is clarified, mod Z square is Z into Z bar. Z into Z bar equal to mod Z1 square plus mod Z2 square plus twice root of mod Z1 into mod Z into Z1 bar. Again by this one, this is mod Z1 square plus Z1 Z2 bar plus Z2 Z1 bar plus mod Z2 square is equal to mod Z1 square plus mod Z2 square twice root of mod Z1 mod Z2. You can remove this one. So therefore, Z1 Z2 plus Z2 Z1 is 2 into mod Z1 mod Z2 mod Z2. Okay. This is the given condition. This is the given condition. actually Z1 mod Z1 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 into Z1 bar is mod Z1 square. Okay. Now this is from this what is the argument of Z1 minus argument of Z2? Let us consider, let Z1 is A plus IB, Z2 is C plus IB. So this is A plus IB into C minus IB plus A minus IB C minus IB is twice to the top. Square root of A square plus B square into C square plus D square. That gives us AC plus AC, 2AC, minus IAD minus I 2IAD, BC minus BC cancel, minus, no, this is plus, Z1 mod, Z1 mod, okay. Actually this is also cancel, this is also AC, 2AC, minus IAD plus IAD cancel, minus plus IBC minus IBC cancel, minus I square plus BD, A is plus BD plus 2BD equal to 2 into square root of A square plus B square into C square plus D square. That gives us AC plus BD square equal to A square C square product of this. A square D square plus B square C square plus B square D square. Now again squaring, we get A, B, C, D equal to, it will cancel and it will cancel. So A square D square plus B square C square. Okay. That may be written as, AD minus BC whole square equal to 0. Once you take this one and making it perfect square, AD minus BC equal to 0. AD takes the value BC. AD takes the value BC. So that B by A equal to B by A equal to B by A equal to D by C. D by C. Okay. Augment of Z1. B by A means augment of Z1 is same to the top. This is augment of Z. Hence it must be G. It must be G. Augment of Z1 minus augment of Z2 must be 0 here. Okay. That is one important one. Of course, both Z1 and Z2 lies on same line. Once it follows, Z1 Z2 lies on same.